This is forward? Okay. There are different types of gravitational and inertial anomalies. And someone previously mentioned something about a pendulum. No, I have a... No.
Back up.
Okay, something, well, actually it was a paraconical pendulum that tended to precess anomalously during an eclipse. And there are several measurements, several people who allege it, different types of anomalous precessions in different types of pendulums. And the two I'm going to talk about here are the eclipse effect and the general Elias effect. And why there is strong seismic evidence for something that acts like the general Elias effect. You know, we can talk about a very small term in gravity, a very small deviation from general relativity and Newtonian gravity. There might be a very practical application of this. There might be strong evidence for it coming from some other field. And I spent more time looking at this and I'm more comfortable fielding questions on that. The next slide, the next presentation I was going to give was going to be my explanation for it. But I think probably it might be more useful to talk about this first. Okay, that's right. The two I'm going to talk about are the
Where's the button for the...
Yeah, I'm catching on. Yeah, I have a slow learning curve. The Elias ellipse effect and the general Elias effect. And I guess everybody here is familiar with the Pioneer anomaly and those anomalies. Okay, this is an illustration by Phil McKenna, and this is a paraconical pendulum. And this is the anomalous precession that some people allege happens during an eclipse. Normally, a pendulum should precess clockwise. What they found, many researchers say they found, is that prior to an eclipse, you get an anomalous precession, or you have a decrease in the precession clockwise. What you would have is an anomalous kind of a counterclockwise torque. And after an eclipse, it either returns to normal or actually turns to normal and then some. This pretty much is what I just said. The northern hemisphere pendulum should rotate clockwise. At the very beginning of an eclipse, the pendulum's rotation will deviate towards a counterclockwise. Afterward, it returns to clockwise. Some people have observed this for both solar and lunar eclipses, and then some people have measured it on the side of the Earth opposite the eclipse. It's been measured with a torsion pendulum, a stationary pendulum, and a torsion balance. And this is an estimate of the acceleration. If you really want to understand this, Hector has edited an excellent book on the subject, and I think it's a must-read. And it wasn't until I read his must-read book that I realized that there is something referred to as a general Elias effect. And am I pronouncing his name right? You pronounce the S? You don't know? Okay. Okay. You have also evidence for an anomalous precession of a pendulum during other various lunar cycles. In the northern hemisphere, the anomaly is counterclockwise as the pendulum's location approaches the sun or the moon. And the moon, and you also get an anomalous precession as the moon or the earth approach a particular point in space. And clockwise, when the reverse is happening, that particular point in space, I believe, is fairly close to the vernal. You know what I mean. Now, there are various periods found in this by different observers using different techniques and different data sets. There was Maurice Elias said he found this in his pendulum measurements, and he also found periods comparable to these in Dayton Miller's ether drift experiments. And John Bagby independently measured these with a completely different setup. Now, these are the periods you would tend to find in a solar day, lunar day. The sidereal month, and a half year. Now, if you want to look at the repeat period of these, what the resonance would be, when they would all be in phase. You essentially get that metonic cycle, or 9.5 years. Now, I did a meta-study of over 200 papers that showed positive correlations between seismic activity and lunar and solar cycles. A lot of people find a weak correlation with local times. It's weak, it's not universal, and most of the correlations, the people who get a correlation with the time usually end up adding a phase, very arbitrarily to get the correlation, phase lag. And quite often it's a phase lead, where you have a peak in earthquakes in certain areas. It comes 3.5 days before the maximum time. It's something. When I first noticed these correlations, I was intrigued by the way different the tides would interact with different geological models. And then I started looking at it. It's not tides, it's something else. You get fairly strong correlations with fortnightly, monthly tidal cycles. But they're very limited areas. They always disappear in global samples. But what you do see in global cycles, you get a weak 4.42 years, a fairly weak 9.3 years, and a fairly strong 9.5 year period. Now, this is not what you would expect to find if you were looking at a maximum local tidal stress. What should really be curious here is that we don't get an 8.84 year period. That doesn't show up, and that is what your tidal models would predict, where you would get. What's different between the periods you find in the general Reyes effect and the periods you find in tidal models, tidal maximums, is that the anomalistic period shows up in the tidal models. The distance between the Earth and the Moon shows up very strongly. It's a very strong tidal term. We don't see that much of a correlation there. You get a much stronger correlation with the 9.5 year period. Now this is a measurement of the volcanic explosivity index. I didn't do this, somebody else came up with it. This was Richard Stallers at Columbia. And if you look at the different periods he has here, you get these, that's right, I have a point on that. You get a spike right at 9.5 years, and his resolution is good enough that you can tell that it isn't 9.3. You get a big increase in seismic activity at precisely the period of the resonance in the general Reyes effect. There was no other explanation. I looked at every other explanation for it. I tried the different models. This pretty much, and I'll clarify one thing. I'm not the first person who said this. John Bagby said this was the main term you would find, and that was before Stodders did this research, came up with this. And you here see the area blown up. You get a very sharp spike at 9.5 years. This spike here at volcanoes with a very high explosivity index is 10.8 years, which is a pattern found more in planetary periods than your sun and moon. This is a study by Hamilton who looked at seismic frequency during a 19-year cycle. And he found the strongest data he found was for a 19-year cycle, not the 18.6 that you would get if you were looking at tides, or the 8.8. But notice, it ends up being two peaks, which are just about 9.5 years apart. You can find specific areas where this is a very pronounced effect. Now, many years ago, I was the physical science director at the Foundation for the Study of Cycles. What they did was tabulated all of these periods with every kind of data they could find. And when you stop and look through them, one after another, I went through several hundred of these. You tend to get two peaks. One that's near the sunspot cycle and one near the 9.5-year period. You can find this in, climate data, rainfall data, tree rings, and the wild animal population. Lynx populations have a very strong 9.5-year period. Now, what I was going to present here was my model for the general Elias effect, which has to do with an ether, and particles are spherically rotating particles in an ether. And if you get ensembles of them, you would start seeing a mild torsion introduced if you have rotating bodies. I'll just go with questions from you. I'm sure many people. Yes.
Hunters noticed that the moon has a strong effect on the activity of animals.
Yes.
And I've been present in one total eclipse. And I noticed that before and after the eclipse, the animals were very active, but during the eclipse, they were very quiet. And so there's something that's going on that stimulates them. And the light fluctuates, and it feels like just being there, the gravity is fluctuating, but not a whole lot, but enough that they can sense it better than we can. So when you were present, I was along the seashore, we had one bird, and all the birds and everything got extremely quiet in the total eclipse. And the moment they weren't that way at all during the day. And so that was quite interesting. So, what does 9.5 years correspond to?
If you look at the anomaly for both the lunar and solar day, they would add constructively twice every synodic month. They would have a period of 14.77 days. You also have periods that correspond to the moon's sidereal month.
So if we were
And you also have a half-year period in the anomalous precession.
If we were to look at the orientation of the sun and the moon and the earth, what would the alignment be that produces this 9.5-year cycle?
It would be essentially eclipses or close eclipses at the same time of year with the same orientation in absolute space. You know, like, let's say that there's a,
Can I answer that question, Martin? If you have a number of cycles which you have, and these, basically, the question is answered, these cycles are back in phase. That means
Right.
you can take any
you
phase
see,
arrangement.
what is the phase?
you know,
They're adding constructively here.
Yeah, it can be any phase. It could be the moon being at right angles to the Earth-Sun alignment. You know, it could be there. 9.5 years later,
You're right.
it won't be
Yeah,
there
you're right.
again. So you could take any arrangement that you want, and 9.5 years later, you be back at that arrangement.
No, I
I think
suspect
it's-
it should be a maximum and minimum of some sort.
Yes.
No, but you can take any one.
Any phase repeats itself in 19 years. That's what you're saying.
Yeah, the whole thing
But-
repeats itself.
But it tends to be,
So,
it tends to be very close to where they're maximized.
but you can have a minimum of 9.5 years.
Yes,
as
yeah, it
well.
would be, you know.
You know, and basically the
Well, see, actually-
volcanoes would maybe be with a peak, you know, who knows?
Yeah, the peak would be where they add constructively. It
Yeah.
does, that is, and predictions have been made on this, and they have been,
Well, one way to look at this is that the Earth goes around the sun in an ellipse.
right,
So at one part of the ellipse, it's farthest from the sun, and one part is closest to the sun. And the moon goes around the Earth also in an ellipse.
Yeah.
And one part of that is when it's closest and farthest. So what I'm thinking is that
see,
every
that wouldn't give you 9.5 years.
when all of them are in phase, it would.
No. The moon's ellipse definitely isn't. That would give you, it gives you another term. If you just look at if you throw out the sidereal term, and you throw in the anomalistic term, you would get 8.84 years. That's what I'm saying, it doesn't show up. You know, it's, the tidal for, if you were expecting a tidal maximum, that's not what you'd get. You wouldn't get 9.5 years.
Well, what's the lag between the time the tide comes in and the sun is over?
Okay, it varies from water body to water body. It's on the order of hours. What I'm saying is, it's been a great effort to correlate seismic activity with local tidal stress. And it's very limited success in very small areas. What always happens when you look at models like that, the synodic month, the lunar phases show up much more, have a much greater effect than they should have compared to the anomalistic. Actually, if you look at the rotation speed of the Earth, where you have tides affecting the movement of inertia of the Earth. Now, there's various fudge terms you can use to try and get an agreement between the theory and what's measured. But what's very consistent is that if you compare the anomalistic term with the synodic term, lunar phase with lunar distance, the lunar phase has a much greater influence than it should have. It fell.
Okay.
You mentioned sidereal periods with respect to a distant star.
Yeah.
What's wrong with our own star? Why do we go out to another star to see how much time it takes to orbit?
Okay.
We should be talking about our solar system.
But it does have a significant term. The
Yeah, but that's what messes it up.
No, the sidereal term would be where the moon is in absolute space, or where the Earth is approaching the term in absolute space.
But so our whole solar system is the same way. Whatever the moon is doing in absolute space, the same thing the sun is doing in absolute space,
But you can't-
without ever having to go to a distant star.
How you
No,
cannot
we were
measure
using
it,
this-
you measure the angle between the moon, our sun, and a distant star. And
Okay,
that
we're not saying
angle is
I'm not
the
saying
same.
the distant star affects
You
it.
need that extra point to measure it.
We're using a distant star as a reference point.
Yeah, but
It's not doing anything.
what's wrong with the reference point of the star, our star itself?
Okay,
Because it moves.
Eh?
No, it doesn't move, you need another,
No,
another
this
point to
distant star
measure.
doesn't move.
If you've got the sun here, you want to measure
They
the
do the
moon
same
to
thing
go
as
around
solar.
here, relative, you cannot measure it just here and here, you need another reference point to measure it. So you want the line from the moon to the sun to the star to be a constant angle, whatever it is.
Argue about it after.
Triangulation.
Any other questions? Time for another question, perhaps, but,
Is there any
Okay.
evidence,
yeah, go on, go on.
any evidence in any of this that the gravity itself is doing something weird?
what is doing something weird?
Gravity, the strength of gravity that is doing something weird, are all these just features of the geometry of the Earth, the moon, three blah, 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 where they're placed and all that?
I think I sort of started with the assumption that either the model that I'm going to suggest actually is an ether model where you would have a torsion in the model which would maximize the these periods.
So you're making another presentation tomorrow?
No.
No, I'm just,
Oh, tomorrow.
actually, the Natural Philosophy Alliance is having a conference immediately after this at the Radisson. And if you want to find the ending, you have to come then.
Okay.
You're invited.
What motivation.
Okay, let's thank Martin and all the other speakers today.